In the previous videos, we're able to determine the direction vector of a line, specifically passing through the points. In this case, you have points P and Q. We're able to identify, again, your direction vector V. And if you're going to write an equation of a line, you're using this vector, you are going to represent it with L is equal to P plus your direction vector V. Or you can also use here Q, but nevertheless, P and Q are on the same line. So we are writing that in that manner. This time, let's try to transform this into the form AX plus BY plus C equal to 0. But we are not going to use the high school method of using this and then using the 2-point form, but we're going to use the vector, meaning we're going to pass through this point before proceeding to this form. Now, in order for us to do that, let's try to plot the points first on this Cartesian plane, and let's say that each grid is 1. So our point P is at 1, so it's somewhere here, and then 2 is here. This is our point P, so you have 1 and 2. And for our Q is -3, and then 5. 2, 3, 4, and 5. This is our point Q, which is -3 and 5. In short, if we would like to determine the line, okay, the line passing through, or the equation of a line, it would be the equation of this line, assuming that my graph is, let me do it again, assuming that my graph is accurate. So we're going to, and it's of course, again, as mentioned, it's a line, so it has arrowheads like that in that direction. Assuming again my line is straight. So we're going to determine the equation of a line in the form AX plus BY plus C, again without the use of the usual methods in our high school years. Now let's start by identifying the direction vector. In the previous video as well, we talked about the process of doing this. We start with identifying the direction vector. The direction vector, we can determine that is of course by subtracting having Q minus P, or subtracting Q from P. Your Q is -3 and 5, and then our P is 1 and 2. That's actually -3 minus 1, and then you have here 5 minus 2. You'll get here -4, and then this is actually 3. Since this is a vector, direction vector, to differentiate that from any point, let's use here brackets. So we have here -4 and 3. In short, if you're going to stick with this form, you can write this line, equation of the line, okay? You can write the equation of this line in a form, okay, using P. Let's use P. P is 1, 2, plus your direction vector, -4 and 3. That is with the use of this. But then again, our goal for this video is in the form AX plus BY plus C. So what should be done here? Now, after this, we are going to determine, all right, the steps are presented again in the previous video. Here is actually that previous video. The scribbles from the previous video. We need to identify first the normal vector, and then to identify A and B, which is into that. And later on, I'm going to focus as well with all the rest. Okay, so you can also view the video pertaining to this discussion. So with this now, let's identify first our normal vector. Our normal vector will be using -v sub 2 and v sub 1, where for our vector, this is actually v sub 1 and then v sub 2. In short, our normal vector is identified as negative of v sub 2, which is a 3, and your v sub 1, which is -4. Okay, this is the first step. Not necessarily the first step, you can count this as your first step, okay? Since we don't have the vector given, we were able to solve the vector first. But if the vector is given, so let's consider this as our first step. The second step here is identifying A and B coefficients intended for our form AX plus BY plus C. It's actually given as this, as our A, and this is our B on our normal vector. Okay? Or in short, A is just equal to -v sub 2, and B is your v sub 1 of your vector V if you will not pass na normal vector. Okay? But since it's like that, so we're going to follow this process. In short, our A is -3, and our B is actually -4. Our third step now will be using this to determine the C coefficient. Take that our goal is AX plus BY plus C is equal to 0. Okay, so we already know what A is, B, but we don't know what C in the meantime. So we'll be using this AB coefficient together with one point, any of the point P and Q, any of these two, to identify C. Nevertheless, whichever we'll be using, the value of C is just the same because point P and Q are just on the same line. Let me use point P here because it's easier for me to use 1 and 2 instead of your Q, which is negative 3 and 5. So with that, you have here AX plus BY plus C must be equal to 0. In determining C, your A is negative 3, your X here is 1, plus your B is negative 4, your C is 2, plus C is equal to 0. So you have here negative 3 minus 8 plus C is equal to 0. So negative 11 plus C is equal to 0. Your C is positive 11. I am urging you to try using Q, which is negative 3 and 5, if you will get the same C. Okay? Because if you will get the same C, then definitely what we're talking about is correct. Of course, you have negative 3 times negative 3. That's actually negative 9. You have 5, positive 9. 5 times negative 4 is negative 20. So 9 minus 20, you will still get value here of negative 11. As you combine that, to C equal to 0. So your C is still 11. So that's actually the same value, whether you will use P and Q. So since that our C, we are not complete, we now have a complete form of our coefficients. So basically just combine them into one form, AX plus BY plus C is equal to 0. But this time, our X and Y would be arbitrary variables. So our A is negative 3. So you have here negative 3X plus your B is negative 4. So negative 4Y. Your C is plus 11 equal to 0. If you would like to come up with a leading coefficient of positive as we usually do before, so we will have here multiplying everything by negative 1. So you will have here 3x positive now, positive 4y now, and our 11 will become minus 11 equal to 0. So this is the form of ax plus by plus c equal to 0 for the given points P, 1, 2, and Q, negative 3, and 5 using vectors. But this is again if you are restricted to use the vectors or passing through the vectors before identifying this. Of course, if you are not restricted, you can of course use the 2-point form. If you can still remember, the 2-point form in our junior high school or high school years, you have y minus y sub 1 minus your slope. So this is our slope, right? Then x sub 2 minus x sub 1 times x minus x sub 1, simplifying them general form into this form. And I'm urging you to actually try this 2-point form and determine if we will have the same result. Nevertheless, this is how we identify the equation of a line in the form ax plus by plus c using 2 points using vectors and not the 2-point form. So again, this is actually written as, if I'm correct, 3x plus 4y minus 11 is equal to 0. Thank you very much for watching.